Good morning. I am R. Krishnamar from Mechanical and Mechatronics Department. Today we will see the theory of machine subject. The unit name is Mechanism and Kinematics. The topic is Slider Crank Mechanism. Slider crank mechanism is one of the most important and widely used mechanism in the mechanical engineering and the theory of motion. It is the basic mechanism that converts rotary motion into reciprocating motion or reciprocating motion into rotary motion. The mechanism consists of four links connecting by three turning pair and one sliding pair. The four link are the frame, crank, connecting rod, and slider. The frame is the fixed link. The crank rotate about a fixed axis. The connecting rod connect the crank and the slider moves back and forth along a straight path. Because of its ability to convert motion efficiently, the slider crank mechanism is extensively used in engines, pumps, compressor, machine tools, and various industrial machine. It is one of the most fundamental mechanisms studied in kinematics and machines design because mainly mechanical systems are based on its working principle. A slider crank mechanism is a basic four-link mechanism that converts rotary motion into reciprocating motion or vice versa. It is one of the most widely used mechanisms in mechanical systems such as internal combustion engine, compressor, pumps, and reciprocating machine. Construction. The slider crank mechanism consists of four link, frame, fixed link, supports and guide the mechanism. Crank, a rotating link connected to frame by a revolute joint. Connecting rod, coupler, connect the crank to the slider. Before going to see the working principle, the working of the slider crank mechanism is simple and highly effective. When the crank rotates continuously, the connecting rod transmits motion to the slider, causing it to reciprocate in a straight line. Similarly, if the slider is forced to move back and forth, the crank rotates. This motion conversion capability makes the mechanism highly useful in practical engineering application. In an internal combustion engine, the reciprocating motion of the piston produced by the combustion of fuel is converted into rotary motion of the crankshaft. In reciprocating pump and compressor, rotary motion supplied by a motor is converted into reciprocating motion to pump fluid or compressor gases. The mechanism operates smoothly because of the constrained motion between its link and joint. The slider crank mechanism is also known as single slider crankchain because it contains one sliding pair. The mechanism consists of one of the sliding element and three rotating joint. The crank is generally the driving link and the slider acts as the driven member. During operation, the crank rotates about the crankshaft center and the connecting rod transmits a force to the slider. The slider then moves inside a guide or cylinder. The displacement of the slider depends upon the crank radius, connecting rod length, and angular position of the crank. The motion of the slider is not uniform because the crank rotates at constant speed while the connecting rod changes its angular position continuously. Working principle. When the crank rotates, it pushes and pulls the connecting rod, which in turn causes the slider move linearly. One complete rotation of the crank produces one forward and return stroke of the slider. Rotary to reciprocating motion, internal combustion engine. Reciprocating to rotary motion, pumps and compressor. Inversion of slider crank mechanism. By fixing different links, various useful mechanisms are obtained. First inversion, crank fixed rotary engine mechanism. Second inversion, connecting rod fixed oscillating cylinder engine. Third inversion, slider fixed with what quick return mechanism. Fourth inversion, frame fixed, ordinary slider crank mechanism. Before going to see the applications, several important inversions are obtained from the slider crank chain by affixing different links. An inversion is formed when different links of the mechanism are fixed at one and a time while maintaining the relative motion between the remaining links. These inversions are widely used in practical mission and engineering application. The first inversion is the reciprocating engine or pump mechanism obtained by fixing the frame. In this arrangement, the crank rotates while the piston or slider reciprocate inside the cylinder. The inversion is commonly used in petrol engine, diesel engine, steam engine, reciprocating pumps and compressor. In internal combustion engines, gas pushes the piston, causing the crankshaft to rotate and produce power. This inversion forms the foundation of the most automobile and power generation application: internal combustion engine, steam engine, reciprocating compressor, pump, mechanical process. Advantages: simple construction, efficient motion conversion, high reliability. Thank you.